Hey everybody. In class today we talked about functions and evaluating them or solving for the input if we know the output. Tonight we're going to look at families of functions. A family of functions is a group of functions with similar characteristics. Functions that have the form f of x equals mx plus b make up the family of linear functions. So anytime we see a function f of x equals mx plus b, we know that this is going to be a linear function, right? All we need to do is look at the equation and we know something about it. We know that it's going to have a y-intercept at b, we know it has a slope of m, and we know that it's going to be a straight line. So that's why it's the family of linear functions. Now, every family of functions has what's called a parent function. The parent function is the most basic version of all of the functions in that family. For linear functions, the parent function, the most basic version, is f of x equals x, right? There's no number that's being added on, so there's no y-intercept, and we have no coefficient here. There's no number written in front, so the slope is just 1. This is the simplest version of a linear function, and the graph of the parent function, f of x equals x, is shown right here. Notice the y-intercept is 0, and we just go up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. That's the most basic version of all of the types of lines that we've been graphing. Every other function we see in the family of linear functions is a different version of this parent function. So let's graph these. I know my y-intercept here is 3. G of x equals x plus 3. I'm going to start at 3. And my slope is 1. So we're going to go up 1 to the right 1, up 1 to the right 1. We also go down 1 to the left, down 1 to the left, right? We got a nice straight line. I'm going to try to draw it straight. Not the worst I've ever done. And let's put the parent function on there too. I'm going to put the parent function in green. Now the parent function has a y-intercept of 0. And we go up 1 to the right 1, up 1 to the right 1. We can also go the opposite direction. And we'll draw a line for that too. Now, looking at these two lines, I notice that g of x is very similar to f of x. The red line is very similar to the green line, but it's 3 units higher. So we can say g of x is 3 units higher on the graph than f of x. For our next graph, we have h of x equals 2x. So here we don't have a y-intercept. Our y-intercept is 0. And we do have a slope, though. The slope is 2. So up 2 to the right 1, up 2 to the right 1, and we'll go in the other direction, down 2 left, down 2 left. And we'll draw our line. And then we'll draw the parent function again. Same y-intercept, but our slope is 1. So up 1 to the right 1, or down 1 to the left 1. And we'll draw the line for that one too. So we notice here, once again, these lines have something in common. In this case, it's the y-intercept, but the slope is different. Our blue line here is actually a little steeper, so we can say h of x is steeper than f of x. So we can actually say that it's twice as steep because the slope for h of x is 2 and for f of x the slope is just 1. Let's take a look at one more example. We want to graph h of x, which equals negative 3x, and we're going to compare it with our parent function again. So h of x equals negative 3x. It doesn't say plus 5 or minus 2, so the y-intercept is 0. So let's put our y-intercept right at the origin, and our slope is negative 3 or negative 3 over 1. So we can go down 3 into the right 1, down 3 into the right 1, and we can also go in reverse, up and to the left, up and to the left. And we see our points now, which are in a nice, perfect, straight line. And hey, look at that. It's the best line I've drawn all day. Now, if we draw the parent function again, we know how that's going to look. Y-intercept is 0, and our slope is 1. So up 1 to the right 1 for each of these, and we can go down and to the left. And here again, we get a straight line, as straight as I can draw it anyway. Now, if we want to compare these functions, and we look at these two lines, we see that h of x is going down as we go from left to right, whereas f of x, our parent function, is going up as we go from left to right. So we can say that h of x is decreasing, right, instead of increasing. It's going down, and it is steeper than f of x, right? Our slope for f of x is 1, so it's going up 1 over 1. Our slope for h of x is -3. So even though it's going in the opposite direction, it's also steeper as well because it's going down 3 every time we go to the right one. So it's 3 times steeper than the parent function. This little chart here is a really handy guide for understanding what happens when we make changes to the parent function. Right? It says that changing m or b in the general linear function g of x equals mx plus b creates families of linear functions whose graphs are related to the graph of f of x equals x, the parent function. Right? So if we take a function and we take x and we add b to it, that can either shift the parent function, which is in blue here, it can shift it up by b units, or if b is negative, it can shift it down, right? Like for instance, right here, our y-intercept is -3, so in our equation we would have -3. But here, our y-intercept is positive, so this would be like a +2 right there. Okay, we call these vertical translations. This is an important term to understand. Vertical translations. A translation is just when we move something around on a graph, and in this case we can move it vertically by changing b. When we change m in a function, it changes the steepness of the graph. Notice all of these graphs here go through the origin, and we have our parent function in blue, and we have a red line which is steeper, so it would have a greater slope than the parent function. And this red line is less steep, so m would actually be less than the slope of the parent function. Okay? When we change the slope, we can either stretch it if the slope is greater, or we can shrink it. We can compress the line if the slope is smaller than the original slope. Now, what gets tricky is when m is less than 0. Changing m still changes the steepness of the line, right? We have different steepnesses here. But remember, if m is less than 0, that means that m is negative. That means that our lines are going to be decreasing or going down from left to right. Okay, I know that was a lot for tonight. Go ahead and finish your notes, submit them, and we will get more practice with these concepts tomorrow in class. And if we get enough practice in class, we do what we got to do, you guys are going to get it, don't worry. All right, I'll see you guys tomorrow. Have a good night.